Hi, this is the podcast on homozygous monohybrid crosses. This is just a very quick review of or why we would need a Punnett square and how to use it. And so if we look at our first example here in guinea pigs, rough hair is dominant to smooth hair. And so we want to cross a homozygous rough-haired guinea pig with a smooth-haired guinea pig. And notice the word cross. All the word cross means is that we have two parents, a homozygous rough-haired guinea pig, and the other parent is a smooth-haired guinea pig. And we want to look at the possibility of what their children could look like. So if we look at the rough-haired guinea pig, let's say we use R as our dominant letter, capital R and little r is our recessive letter. And so um, we have a homozygous rough-haired individual, so their letters would be RR, and a smooth individual would be little r, little r. So let's say these two want to have kids, and in male, all the cells have RR in them. But if we want to make sperm cells or go through meiosis, we need to make sure that, or the egg cells in meiosis, we need to make sure that you're donating half. Because if you made cells that were not half, then you would end up with too many chromosomes or too much genetic information in the individual, and that's not going to be good. All right, they would have four genes instead of two, and so it's really important that again um, we remind everyone that parents donate half their genetic information, and when they go through meiosis, they're donating half. So if one individual is big R, they're going to donate one big R to their offspring. Right? If this individual is little r for smooth hair, that means they will donate one of their R's. And that way, when the sperm and the egg get together, you're going to have an individual with the correct number of alleles and chromosomes. So keep that in mind that each parent always donates half. So we look at the Punnett square. Punnett square is just a device, a box that we write to show the possible offspring. This is not saying that an individual is going to have four children. It's just saying that these are the possibilities. So let's say we put the letters on top for the homozygous rough-haired individual, and let's say we put the smooth-haired individual on the side. So I'm going to move my recording thing, and again, this is what we call the cross. So again, keep in mind that each parent is donating one letter. So in this first box, if the dad donates the big R, the mom donates the little r, this is what the individual would have and look like. It would be a rough-haired individual because the big R always wins. In the second box, we would have a big R and a little r again, and we'd have a rough-haired individual. Third box, dad donates big R, mom donates little r, and we have a rough-haired individual. Again, the big R always wins. And in the last box, the same scenario where we'd have another rough-haired individual. So this is how you do Punnett square. So there's two ratios or two ways to interpret this box. The one is to look at the letter combinations of all the possible offspring. So in any given Punnett square, you're always going to have two capital letters, two lowercase letters, or a heterozygous. These are all the possibilities. I'm not saying that that's going to occur, but these are the possibilities. You would always have a possible homozygous dominant, a possible heterozygous dominant, I'm sorry, homozygous dominant or recessive, let me rephrase that. You will always have a homozygous dominant. You will always have the possibility of a homozygous recessive. And you will always have the possibility of a heterozygous. So if we go back to the box again, all right, all of the individuals are heterozygous, big R, little r. So that means the ratio would be 4 big R, little r's to 0 everything else. You could also express this in a percent. You could say if these two individuals have kids, this homozygous rough hair and homozygous smooth hair, it is 100% chance that they will have a heterozygous offspring. So that's one way of interpreting this Punnett square. The other way is to look at the phenotypic ratio. And we have two scenarios. We have a rough or we have a smooth. And because all of them have at least one big R in it, they're all going to be rough. This concludes the short presentation of Punnett squares.